this leader here. I wanted to work a homework problem from this week's homework set. Looked like this one people were spending the most time on, so that made me think it might be a bit difficult. So let's talk about it. Looks like we are doing a long-term study of the population of American black bears. I don't know if any of you have ever seen a bear. I've seen them while mountain biking before. It is terrifying. So this study, we're looking at a model that could be used to predict a bear's weight, and it kind of makes sense. You wouldn't want to weigh bears in the field. So one possible variable that's related to the weight is the length of the bear. That kind of makes sense. So here is a data set, and notice that you can uh, look at the data set. You can click here to get this opened up in StatCrunch. And so I guess I started recording this video and then I realized I needed to practice it more. But so I already answered this question: which variable is the explanatory variable based on the goals of the research? That's the length of the bear, because that's what we want to use to predict the response value, which is the weight of the bear. Now let's draw a scatter diagram. So I'm just going to go ahead and do this in StatCrunch, because this is a nice little applet that is integrated right into your browser. You don't need extra software. So here's a tutorial you can click on if you want. I'm just going to select all the data with a Command A or Control A if you're a Windows person, and I want a scatter plot. So I'm going to click Graph, and I'm going to click Scatter Plot. So I have to choose the X variable, which is the, what did we call it, the predictor, or the, so we know that that's going to be the length of the bear, and the response variable is going to be the weight. All these other things are optional, so I'm going to skip them. And there's a scatter plot. So now I'm going to go back to my window, close that. Explanatory variable. I'm sorry, I couldn't think of the word that the text used. And so now, which one of these is going to be the one we want? So we can immediately eliminate B, because that shows a negative correlation with length and weight. And a longer bear, I doubt, would be inversely related. A longer bear is likely to weigh more than a smaller bear. Maybe not in every single case, but in many cases. So now I have to find StatCrunch again. All right, and there's our scatter plot. So now look at all these fun options we have. We can zoom if we want. I'm just going to look at these data points here and try to figure out which one of these is the best match. So I'll make this one a little bit bigger. Notice that 10, 100, 20, 40, 10, 20, 30, 40, 50, 60, 70, 80. So these tick units, ticks are 10 units apart, 10 centimeters apart. So 120, and it looks like 40, 50, 60, 40, 80, 120, 140, 60, 80, 100, 120. So these are 20 kilograms apart, these tick marks. So 140 and 60, is that a point on any of these on my scatter plot? So it looks like this is 140. So let's look for a scatter plot on our problem that has that point. So 140, now let's look at our StatCrunch, 120 and 60. So we need to find a point that is at 120 and 60. So it's not looking like this one. 120, I'm liking this one. Let's just double check. 120 and 60, right there. I'm liking that. Let's pick it. Oh, oops, I did that wrong. How did I get that wrong? We better look at that more closely. So this is a little bigger than 120 and right around 60. So I better look at these again. Definitely not that one, as there isn't a point at 120, 60. Let's take another look at this one. I thought I had it. Oh, it's because the tick marks down here are 10 units apart. There's 120, there's 160. So do you see how it's important to make sure that you get the, what am I thinking? Don't be careful about the scale. There we go. Determine the linear correlation coefficient. So now we're going to go back to StatCrunch. I'm going to hide this. And I want a regression. No, I want a correlation. And we'll find it in here. So now I'll pause this for a moment and we'll just run a simple linear. Total length is the explanatory variable, weight is the response variable, and we don't need to perform any hypothesis tests, so we're not doing any transformations, and we should get the correlation coefficient. There it is, 0.71. I'm going to just copy that, and then I'm going to paste it, but then I'm going to check that I need 3 decimal places. 713, that's a 9, so we'll make that a 4. And there's the correlation coefficient. Because the correlation coefficient is positive, and the absolute value of the correlation coefficient is the same number, and now we have to look at the critical values table. "12 American black bears." So we're at n equals 12. Oh, geez. N equals 12.576. The positive linear. Oh, I have to put the critical value for the data set in here, the data table. Oh, data set. 0.576. And there it is. So that's how you solve that problem. And notice that if you want, you can go back to that question if you weren't comfortable with that and do a similar question and do the whole thing again with a slightly different data set or with some changed feature. All right, thank you. I hope this was helpful.